Welcome to the world of physics. I bet you're watching this video because you're about ready to throw your physics textbook out the window. Don't do that. Broken glass is dangerous. But consider a description how your physics book moves, say 3 meters right. Each word conveys a different type of information. 3 is a number, meters is a unit, and right is a direction. The unit tells you important information about what the number means, so it makes sense to group units and numbers into something called a physical quantity. Examples of physical quantities are 10 seconds, 5 kilograms, and 3 meters. None of these physical quantities have directions, so we call them scalar physical quantities. If we add a direction to a scalar, then we have a vector. A vector is just a number or magnitude with a direction. In physics, the unit will also be involved, so we have a vector physical quantity, like 3 meters right. Let's represent that visually with an arrow. The arrowhead points to the right, just as we'd expect, and the length of the arrow is proportional to the magnitude of the vector. The bigger the magnitude, the bigger the arrow. Now let's say you go move your physics textbook 2 meters left. Notice that the new arrow starts where the old one ends. That's called tip to tail. Also notice that this new arrow is pointing left because that's the direction you move the book. We can imagine an object, like your textbook, moving along the first vector and then the second vector to wind up somewhere new. We can draw a third vector to show how far this book is from where it started. How do we calculate how far that is? First, let's say right means positive and left means negative. We move positive 3 meters, then add a negative 2 meters, and that sums to a positive 1 meter. We always add vectors, and then let the signs sort themselves out. The vector sum is the displacement, which is how far and in what direction an object has moved from its starting point, regardless of the path it takes. Because we found it by adding vectors, displacement is a vector quantity. Now, wait a minute. The book did move 3 meters and then 2 meters back. That's got to count for something, right? Well, yes. We can also add only the magnitude without the direction, so there are no arrows. 3 meters plus 2 meters equals 5 meters, which we call distance. Because we found it by adding scalars, distance is a scalar quantity. How do we know which are scalars and which are vectors? Each vector quantity has a symbol for one of those 3 types of information we talked about earlier: direction, number, and unit. But each scalar quantity only has a number and a unit. Now, why have I been using so much red? It's to emphasize that all these vectors have been in the same dimension, forwards or backwards on the same line. We can also have vectors in 2 dimensions. Let's say that after you threw your physics textbook 3 meters right, you moved it 4 meters forward. What is the distance traveled and the displacement of the book? To find the distance, we just add the magnitudes. 3 meters plus 4 meters equals 7 meters distance. To find the displacement, we add the vectors tip to tail, just as they are laid out here, and then draw a vector from the initial position to the final position. This is called the resultant vector. We realize that the directions you move the book are perpendicular, so we can use the Pythagorean theorem to find the hypotenuse of this triangle. We conclude that your book was displaced 5 meters in 2-dimensional space. But wait, we don't know which direction it was displaced. To find it, we need to know the measure of this angle, which we get by taking the inverse tangent or arctan of the opposite over the adjacent. One more thing to know about vectors is that you can add them in any order you like. This holds true even if you have a lot of vectors, no matter the angles between them. Wrapping up, remember that every vector physical quantity includes a number, a unit, and a direction. Also remember that displacement is a vector representing how far an object traveled from its starting point, while distance is a scalar representing the length of the path it traveled. Finally, for vectors in 2 dimensions, arrange them in a right triangle and use the Pythagorean theorem and trigonometry. Next time we'll get moving on speed, velocity, and acceleration.